All right, thanks everybody for joining today. And thanks again everybody who's been patient with us as we've had to reschedule some things due to people getting busy with travel again and holiday vacations coming up pretty soon. So I'd like to introduce Marco Schwarz from RNP, longtime listener. I don't think you've given a talk before, Marcos, but certainly
First
correct me
time.
if I. Okay, you are first time then. So we're happy to have you here talking about some of the work that you've been doing with containerization and learning how that may impact or help the deployment and operation of DTNs. So I will throw it over to you.
Thank you, Jason. So yeah, I'm Marco Schwarz. I'm R&D manager at RNP, and I've been working with Persona for more than 7 years. And in this time, I've been following the containerization trends at Kubernetes, and I've been looking for some features or some opportunities that they're maybe not 100% ready, but they are coming pretty close. So I want to give here an idea. It's a hobby project that I have, and the basic motivation is when we do testing between different environments, for instance, from different universities or sites using DTNs, we normally we are restrained to the production environment that we have. For instance, normally most of the DTNs and personal devices are based on CentOS 7, and it's very difficult to change these characteristics and impact directly the performance or the, I would say, the expected performance that you get. So also, if you some other machine on the same site has a different OS, it will probably behave differently because the code is different, the kernel version is different. So this idea here is trying to see how can we parameterize the kernel as one of the parameters of running a container or a virtual machine, so that you can either bring new features, for instance, have some recent optimizations on TCP on kernel 5.17, and also there are BBR2 and big TCP, another enhancement that is coming on the next main kernel version. So the idea is there a way that we can easily prototype test these different new features, and maybe also try to generate expectation of different systems on production without having to reinstall the OS and change the kernel for the whole system. So in this search for a solution, I bumped into Kata Containers and some other tools that we're talking today. So initially this, it's a little bit important. So the idea is to talk about Kata Containers, which is this different backend for Docker and Containerd that actually runs virtualization, but the behavior is similar to containers, and it's compatible with Kubernetes and Docker-like CLI. We're talking about Containerd, which is one of the components of Docker that in itself, it's currently a separate project, and it enables some features that are not yet exposed in Docker. Nerdctl is a different CLI. It's similar to the Docker CLI, it's heavily inspired, but the idea is that Docker CLI is very backward, it's production oriented, so new features take some time to go into. So Nerdctl can be seen as a bleeding edge CLI to Containerd, so we can explore new features that we're using here. And then I show some results that I've been working on. Regarding Kata Containers, the idea is that there's a lot of discussion regarding security in containers. So you can have a very low barrier for isolation and big performance. And as different options and solutions came out, we have now a very complete set of a range of solutions that we can go to almost as much security as VMs or even use VMs inside containers. So in this way, Kata Containers was one of this initiative of trying to bring lightweight virtual machines and explore them as containers, and also trying to integrate different hypervisors, for instance, QEMU, which is very common, and also new ones like Cloud Hypervisor, which is a hypervisor based on Rust, is more recent and have new features, and also Firecracker, one that's very common to be used in AWS for serverless. They developed it for it. So the idea is to bring security, maintain compatibility with container, the container experience with the images, with the CLI, so that you try to not explore all the features of virtualization, but most the facilities, the ease of use of the containers, and also trying to bring performance and generate simplicity. In this sense, comparing traditional containers to Kata containers in the right, we normally have a single kernel in the host, and all the containers are just different namespace, different C groups, isolating each set of application. In this case, all the applications have the same kernel, so they have the same features, they have some kind of isolation and different parameters that can be set for tuning in them. But in the whole sense, normally you have a single kernel version that can be exploited, and if you exploit it, you have vision to all the other scopes. On the left side, the difference is that for each container, you run a different kernel instance, so that you have one more barrier of isolation using virtualization. But the idea is also to try to disable a lot of features, so that you have a very low footprint virtual machine that boot as fast as a container and has a very low memory and CPU footprint. And in this case, my objective here is not to use the isolation itself for security, but actually isolation to bring new kernel versions and try to see if you can run it in a high performance scenario. So, sorry. Oh yeah, so this is one. So in this sense, the Kata container networking, normally it behaves as you have the host with the physical NIC, you have a bridge, it's very similar to a container, and then you have a virtual Ethernet interface that talks to the VM that is stitched inside a container. So in this sense, you have the container workload, your image, CentOS image or application image inside a VM, so that this VM brings you the new kernel features. And on the right side, we also have a different approach, that is the high performance one that I mentioned, is that you can pass through this physical port, this NIC, or either a virtual function of it using SRV directly to the VM in the container. So in this sense, you'll be bypassing some of the overhead that you have from going from the user space, networking inside the VM, to the kernel space inside the host, and then to the NIC. So I'll bring some graphs trying to compare these different approaches of using bridges or pass-through, and then I'll say some conclusions, what I'm working on. Just some context. So the Kata Containers project started in 2017. It was actually a merge between HyperSH RNV software and Intel Clear Containers projects. One bring multi-architecture and some Kubernetes integration, and Intel Clear Containers were very focused on high performance and some interesting ways to pass host directories and folders inside the VM using zero transfer copies and other approaches. And then on 2019, Kata 2.0 was presented as one of the re-architectures to try to reduce the management footprint for it. And one of the main features is the support for the V2 API. So this is an evolution to the OCI V1 API that basically presents how can you run and manage a low-level container. So in this case, it was enhanced to implement some extra features that can be used to try to manage VMs. And this feature is still experimental. It's not yet supported in Docker, neither in Podman, but can be used directly in Containerd using the Nerdctl, as you show soon. Also, it supports new hypervisors, for instance, called hypervisor. So in this is just a different way to show it. So have Containerd, and you can either use the CLI or a kubelet, a Kubernetes component to instantiate these containers, and it basically has a shim API to manage different kernels and containers running inside the sandbox. In this case, so the base 2 user experience that is possible is to manage your own host locally using Docker-like CLI, or you can use Kubernetes and have a central control plane that you can manage a lot of a cluster of different workers that run this kind of solution. Regarding hypervisors, so the basic tree that I'll be looking into is called for Cloud Hypervisor, Firecracker, and QEMU. And they have different approaches. QEMU is the most well-established and older project. So it have the most features, but it has a lot of, I would say, default code that's not too important currently today. So when you want to port a workload as is running on a baremetal to a VM, you need to virtualize a lot of hardware, BIOS, and complexity that when you have cloud native elements, or you're not, your application is not tied to a specific hardware, actually you can throw out a lot of those virtualizations and emulations, so you can have a less footprint and more performance. In that sense, these two new hypervisors, they're trying to work on this new way of virtualizing. Firecracker is the most slim one, but it doesn't support, for instance, PCI devices, so it doesn't support pass-through of virtual devices to the VM, so it won't be used on this experiment that I'm doing right now. And but Cloud Hypervisor, it for sure can support these features with minimal footprint. So also the other component that I'm going to show is Containerd. It's, as I said, basically is a CNF project that tries to focus on the usability of what is called the low-level container management. So in this sense, it was created in 2017. It was based on Docker Engine 1.11 that basically disaggregated the Docker engine that was a single monolith into these three components: Docker Engine as an aggregator and a manager, Containerd focused on the low-level container features, high-level container features, and runc actually to run each specific container. So the idea is that runc is responsible for each instance of a container, and it supervises the lifecycle of a single container, and Containerd does all the high-level stuff that is necessary to work on lifecycle between containers instances. And in 2018, it presented the Run2 V2 API. In this case, it has runc integration, so it's integration between the Docker CLI and other components to the runc implementation. It supports multiple runtime environments. So another change is that now you have runc as a standard way to run containers, but you can have multiple ones, for instance, gvisor or Kata Containers or some others that I will show in a picture soon. And other than that is daemonless also, so it's part of an evolution of Docker to not being based on daemons, and also currently it also supports rootless containers features and some others. So this is basically the ecosystem of Containerd. So in the upper part is used by main cloud providers and many virtualizations and container solutions. It can be used by clients from Kubernetes, Docker containers, BuildKit, which is the standard way of building containers either on Docker or as a separate component. And CTR is the native CLI from Containerd, which is not very user-friendly. So Nerdctl came after as this Docker-like CLI. In the API sense, it supports the CRI interface, which is the default interface for Kubernetes containers interface. And in the low side, we can see some of the different backends that it supports. runc is the standard one, also supports crun, which is the one used by Cryo, supports some backends for Windows containers, Kata, Firecracker directly, gvisor, which one's from Google that tries to do some, it doesn't use virtualization, but tries to run a similar standard kernel API, so you don't access directly the APIs from the standard kernel. Yeah, and you have here the V2 client, as I said. So in this sense, what I've been using in these demonstrations to try to bring these features is the Nerdctl in the right, which is just added to the feature, and the Kata backend that expect to bring something between VMs and containers. So the last element is the Nerdctl, which is a Docker compatible CLI for Containerd. So the idea is to have a very similar UX than Docker, but also expose some features from Containerd that are not in Docker itself. So it supported rootless mode before Docker released recently. Also, it supports lazy pooling, where you can run a container before finishing to download all the images. Also, some initial support for encrypted images. I need to talk about this. So, as I said, the idea now is to use this runc v2 API. And also one different that I'm not using right now, but can be interesting, is that the networking plugin ecosystem from Docker is called CNM, and it predates the CNI ecosystem, which is used by Kubernetes. So in this sense, Nerdctl is also interesting because it uses the Kubernetes native networking plugin. So it can have the same experience and have SRV, OVS, BPP, a lot of very common CNI plugins, so that you can have the same experience on your local machine and a Kubernetes environment. So this is very interesting also to be explored soon. So my testing environment, basically I have two servers that are directly connected, and they have this Mellanox Connect X5 NIC, and I'll be doing some 1, 2, and 4 flows for 60 seconds. And I've ran some different experiments. Initially was to try to compare the different networking plugins, and more recently I'm trying to run all this using the Kata containers to achieve the same performance. So the initial results that I got, they're kind of interesting. From the left side to right side, I was trying to compare running baremetal, the first run. So the blue bar is 1 flow, orange 2 flows, gray is 4 flows. And also the lines are different CPU usage for 1 flow, for 2, and 4 flows. In this sense, I was then trying to run the same workload, the iPerf application inside a container, and trying to see what is the overhead, and then trying to run it inside the VMs. And then I move on to running a different network plugin called MacVLAN to see if the performance was better. And later on, as I said, there were some limitations on all the previous one. I started working, as I said, with SRV pass-through to have direct access to the NIC. But back then, it was not working on Kata. It's currently working. So I did it using Vagrant and libvirt, which have a similar virtualization characteristics. But in this test, it has some interesting conclusion. For instance, you can see that the baseline for the baremetal is around 42 gigs for 1 flow, 72 gigs for 2 flows, and around 85 gigs for 4 flows. These are running on a Ubuntu 20.04 version with kernel 5.4. And as you move to containers, so no virtualization yet, you can see a huge drop on performance. And this is basically because the bridge, I read that somewhere, but never saw some specific results. It imposed some limitations on the processor. So one of the options is to use MacVLAN. So it's not a bridge, it's just a way to stitch a VLAN from your NIC to a container using kernel networking, and it has a much more similar performance than the baremetal. So if we're trying to run your containers, one suggestion is not use the bridge networking when you don't need, and try to use MacVLAN is performance what you need. The bridge is interesting because it brings NAT and other advanced features, so it's more interesting for user experience, but not for performance. So then when I use the bridge into the virtualization environments, then we still continue to have a low performance and even get lower performance when we consider the multi-flows. So basically it doesn't grow as expected. Now, when you move on to MacVLAN, things get a little bit better. So when you run Kata Kemu, we can get around 30 gigs compared to 40 gigs on virtualization. For 2 flows, we get around 55 gigs compared to 72. and with McVLAN also we get around 80 from 82. But in this scenario, what you see is that the CPU usage start to enhance a lot. And looking a little bit more is because to connect the kernel networking stack with the VM networking stack, you have what is called vhost net. If I remind it correctly, and that is a process that copies all the networking messages from one scope to the other, and it basically uses one CPU for each 30 gigs of traffic on my machine at least. So in this sense, when you have here around 12% of usage for one flow, we go to up to around 30. So it basically doubles. And when we talk about true flows, it goes from 25% or 28% to basically 50%. And when we talk about free flows, actually to run a 90 gigs, we just need a three, I would say the hostnet CPUs plus the 4 CPUs to run 4 threads of hyperv, and then we get around 80%. So in this sense, I didn't consider this a good approach for running virtualized containers or visualized workloads and try to reach high performance. So in this sense, I started to investigate SRV, and here you see a very similar benchmark performance than we had on bare metal. So initially, we have a overhead on the CPU for one flow because the VM was just initializing with 2 CPUs, and it also, as a VM, run a lot of different processes duplicated inside the VM. But when you see the test for 2 flows, you see that basically start to match, and 3 flows to match the bare metal with just a little overhead. But in this sense, we got the similar 40 gigs performance for one flow and got around 62 from 70 gigs of performance for 2 flows, and for 4 flows, things were much closer. One interesting thing that I did and I started working on later on is that by then there was this new version 5.7 that had these 2 patches for TCP optimization, and I was trying to backport it to the VM and see if I could get some better performance than on bare metal. So in this specific occasion, I could run a VM with a different, it's a Zen mod, it's a very tuned a kernel that backported the TCP optimizations, and I could get some very interesting performance, even higher than I had on my bare metal. I still need to study a little bit more to see how this actually works, or what are the tunings that do all these increments, because I'm currently trying the vanilla 5.17 kernel and not getting the same results. But then just to share these results, I've started to build a tutorial, kind of a step-by-step way on how to run it. And this is just an vision of all the different solutions that we have and the one that I'm trying to work in here. So in this case, in this tutorial, I'm currently tackling Nerdctl. As a CLI, I will have a very short tutorial soon that is accessing containerd, and through the Run2 v2, the runtime v2 API, it accesses Kata containers, and we use KMO as the virtualization. All the blue box are basically different paths that can be explored in the future. So you can try export called hypervisor, and also run all these deployments using Kubernetes to have distributed control plane, a central control plane, so distributed infrastructure, and having the same features export to a cluster. And all these red components are the ones that doesn't support currently this approach of v2 API and the Kata containers, but there are existing pull requests and issues on Docker and Podman to try to implement that API, and maybe this will be more accessible in the future. So right now, I just want to give an overview about this tutorial and just do some comments to show the basic experience of the solution. Just a second. Stop sharing a little bit. Then I'll go to conclusions. So it's still a work in progress, a document, but basically what I'm trying to show here is to define better my environment and the way to install it and configure everything. So using latest Mellanox OFED to as a driver to the NIC. We need to enable SROV directly on Mellanox elements. We then do some configurations regarding IOMU, which is required for SROV pass-through. Then we install a Docker. We're not using it directly, but currently Containerd is not packed on distributions. So the best way to use it is to install the Docker repo for your distribution and install Containerd as one of the components. So in this case, we just run it. Also, Kata Containers currently, you have some ways of installing it. It's supported on CentOS 8 and Fedora repos, but not on the other main distributions yet. So the best way that I've found is either to install the binary by itself, which I don't think is a very Snap, which is kind of an image application distribution system from Canonical, and it's supported on most of the distributions. So in this case, you can use Snap, and then you download the latest version of Kata. This is a different, it's a distro-agnostic application delivery system. So it has some differences from traditional applications. For instance, all the images are immutable, but it is an interesting way to deliver and have an easy to configure way. So after installing, you just need to create some symbolic links and do some configurations. Also need to enable vSock, which is a module for communication between the VM and the host. And then we installed the Nerdctl. So Nerdctl itself also is a new project that doesn't have, still doesn't have, it's not packaged on the main distros. So in this case, we just download the binary and we do some different configurations so that it can be run by a standard user without having root access. Also install the CNI plugins, which I won't be using in this tutorial, but they can be used soon for dynamic IP configuration and also to use OVS and other elements that support SROV for the acceleration, but can also provide some easy VXLAN and other tunneling configuration for this environment. Then we create one SROV. We do some tuning for a CPU, for the NIC, and for interrupts, and yeah, some configuration. And then we start running the elements. So the Kata part, what a user could do is two things, mainly to build a kernel. So it has some scripts to do that. So in this case, we're cloning the Kata containers so we can have access to the applications that can build kernels. We then need to customize it a little bit. So it's a very minimum kernel. So it doesn't support, for instance, drivers for any physical NIC because it's running on a minimal VM. So in this sense, we need to configure all the kernel modules for Mellanox 5 drivers. We can do similarly for different NICs. And in this sense, I'm using all of them as embedded, not as modules, in the sense that I just need the kernel image with everything, because I won't be supporting many different hardwares. If you want to have a generic image, one idea is to put them as modules, but also you need to change the root image of your VM to support everything. Other thing is also doesn't support many of the standard TCP congestion protocols by default. So in this case, I'm enabling HTTP cubic and BBR2 in one of my images. And I put cubic as the default, as it is on most of the distros that we are used to. By default, the Kata kernel image, it uses only, it uses only Reno and BBR. And then I've just some extra configurations, and we can then move on to building the kernel. So actually what you just need to do is define which version you want, and you will download automatically from with this build script, you download automatically from the Linux repository and we'll start building it using all your specific parameters that you define above. Also, what you can do, for instance, here, I downloaded BBR v2 kernel, and then I can just path as a parameter the path of that custom kernel, and also I can create that kernel so I can experiment that easily. Yeah, so given all that, I'll just try to show a little bit about the user experience, and then I can move on to my closing arguments. Okay, so I just rebooted my machine before starting, so sorry, just need a little bit of time.
If you can make that text a tiny bit bigger, that
sorry, yeah, sorry, I remembered of doing that yesterday, but I forgot. So let me just see how can I do that.
No problem. We're all old and we can't see it.
No, I thought of it yesterday, but I was focusing on some of the material and I forgot to do it actually. I'm not sure how to do it, so I'll try to find here. Just look at Google. Or I can try to do it differently. Just a second. Let's see if I can do. If anyone knows how to do it, I can do it faster. Sorry.
I'm not really familiar with that. Okay, Nick Adair says try Control and the mouse wheel.
Yeah, I tried that. It worked on some, but not on this one. Yeah, there is. Oh, I need to do input. So yeah, so I will do it on this.
There we go. That's easier to see.
Screen here. So I just want to reaccess. Yeah, I just reaccess my machine from there. Just a second. Yeah. Sorry. Okay. Okay. So I just access again. Okay, so this is my DTN. And the idea here is to kind of give some initial, let's say, from easy to advanced features of Nerdctl and Kata. So in this instance, Nerdctl is just need to run. I just reboot it. Just a second. Containerd. Okay. So right now I have a very similar CLI than I have with Docker. So I can do all the same, almost 90% of the same actions. I can run containers. I can pull images. I can list images. So for instance, I can here see sorry, it's Nerdctl. Yeah, I can see what is running. Actually, nothing yet. I can see the history, but what has been running. So a lot of things that I run today. I can also see the images. And you have all the idea is to have the same parameters so that someone that's very used to Docker can start using Nerdctl very easily. So these images that I have. And one thing that I can do easily is just run one container. So in this sense, I'll just run a standard container with CentOS. Just put to remove it after it. So yeah, now inside a container, this is a traditional container running CentOS, and I'll have the same image that I have on my host. I didn't show it before. And if I want to run a Kata, I just need to change one parameter, and now it will be inside a VM. So let me just show it here. I just don't have it by head. So I just copy it from a different one. So the first thing that I want is to define the runtime environment. So by default, it uses the runc, which doesn't run virtualization. But if I only change it to use Kata v2, now it just take a little bit more time. And then now I'm inside a container with similar features, but now I am running on kernel 5.15. So the idea here is to start to build on this so that I can try to have newer versions of the kernel with different features and start using it. So in this sense, I also doesn't have much. Oh, sorry. I just use a different image that has some tools that I need. Tutorial. I just created this yesterday. So right now, I can see that similar to a Docker container, I have just one interface, which is a bridge interface to the world, so that I can have access to the internet. So it's a very similar experience that than Docker. But the idea is that I can get incremental approaches now. I just need to get one command, so I can paste here just a second. So I just configure the SROV. So this is so that I can have a virtual function on my host. Sorry. So in this sense, how can I show that? I have this 100 gig NIC, ENP 85S0. And the idea now is to create a virtual function or a virtual copy of it so that I can stitch the same 100 gig NIC into a container, into a VM, and continue using this in the host. So I just need to run some commands. This one is to create the VF. The other one is just to find out the different PCI IDs. And then I create it and pass it to the driver. So now what I can do, second. Now I have this 97 VFIO device. I can just go back to my command. And then I can just use device. And then dev VFIO 97. And now I have the same experience running a container inside a VM, but now, sorry, it has, oh, why didn't work? What is wrong? Just a second. You see why I didn't import it. Just run the commands again. Okay. Sudo driver CTL list overrides. Yeah, it's right there. And then we just get the complete command from here. So this is a very long command. Just try to run it with less, because I want to do incrementally so we don't get lost. Sorry, let me try it here. Okay. Okay, it's already running. So just finish this container and try to run it again. Just a second. Yeah, so right now I have a different interface. And if I look here, it's 100 gig NIC and it's running the Mellanox driver. So this is the next part. And then from now, I just want to show the other parameters that we're doing. So that the idea is that you can pass on to different elements. So in this case, the first part, so they can have some capabilities to do some networking changes inside the machine. I think that's what was missing. Then I have the runtime for Kata containers. Then there are some labels that you can pass some different parameters. So initially, I was not passing, just remove some things here. I'm not passing a kernel as a path. So using the 515 kernel that is standard for Kata, as you can see here, uname.r, -r. But when I put the parameter there, what actually we'll have is that I will load this kernel dynamically. And the idea is that I can build and download new kernels on the machine and run them without needing root access. So it's something very interesting. Maybe you can use exploit and also you can block it on Kata. But if it's something that's interesting for advanced uses, is a good approach. And last, I just want to show that I have another kernel here, which is 13.20. Not 13.20, 2012, I think it's, just a second. That is my BVR kernel. So right now, BVR v2 kernel. I have very rapidly changed to a different kernel, and I can just show here cctl -a, I'm just And I can see that this kernel has Reno, BBR, BBRv2. So the idea here is to have a very easy way to move between all these and keeping this fixed scenario. When you talk about troubleshooting network expectations, you're keeping the locations stable or fixed, and you're just shifting the application kernel in a sense that you can compare different probes or tests done in a similar in a closed time frame, and trying to see if there are better ways to troubleshoot or better protocols, or to compare different new protocols and see what is possible. So I showed mostly what is working on Kata, but of course there are a lot of things that need to be worked on. For instance, I can't run right now the standard persona containers because it either use supervisor D or use system D, and for using those two kinds of containers, there are still some issues that have been either regressions or feature not supported on Kata. But this is some interesting initial, I would say, elements that can be used for this experience that I said, to have a way to shift easily the VMs from your environment without reinstalling and changing the host itself. So I just come back for some closing thoughts. And that's all for now. One thing that I was expecting to do also is to do a live transfer here to reaching the 100 gig or something similar, but I'm having some strange behavior with this 515 kernel on baremetal as on virtual. So I'll try to follow up in an email with some better results, and I'll update the tutorial that will be available with the presentation with the next steps. So in this case, some conclusions that Nerdctl and Kata, it has some interesting potential of trying to bridge this experience that I said, of having some easy of use from containers, but trying to port kernel versions and networking features easily to our production environment without changing it a lot. But it has a lot of regressions and still maturing a lot of changes. So I'm trying to contribute with some issues and see if we can get a good set of features that can be interesting for this scenario, this use case that's not the main one for their usages. So we still need a lot of community effort on both projects so that these more niche use cases are supported. We can do all of this that I showed with libvirt and Vagrant in a very similar, easy fashion. But the difference is that you have a stable image, a full image with the kernel, with the rootfs, and fixed to a specific distribution. In this Kata Containers approach, you pass the kernel as a parameter and the image that we use in the application as another. So it's a little bit different. So that I expect that for now, the most stable way to run a new kernel is to install a Ubuntu VM or a state-of-the-art VM, downloading a kernel. There are mainline kernel repositories for Ubuntu, for Fedora, for a lot of these distros, and you can try to experiment. So the idea is to try to make it more accessible to have this experience soon. And future work will be to explore some native pinning, CPU pinning without root access. Currently, to run my experiments, I have to do a lot of hacking to find out what are the processes IDs and trying to create CPU sets, which are a way to dedicate CPUs, and doing that all by hand. So I want to see how can this be integrated. So basically this is solved already, but for Kubernetes, since Kubernetes managed the whole CPU control in the host, but Docker, Containerd, and Nerdctl doesn't do that. So the idea is to try to find a native way to do that easily. Another approach is that currently I need to configure my whole network or the IPs, the VLANs by hand, using the device flag that I showed. And there are some SRV CNI plugins that do this all automatically. So the idea is to have infra as code to define your whole NIC, IP, and everything else, and it will be configured automatically. And also, as I said, there are some other interesting plugins that can be explored. And the idea is to use plugins to support SRV. For instance, there is a accelerated bridge plugin and also this OVS plugin that supports the SRV offload. So I'll try to move on that, and maybe by the end of the year, give some updates regarding this. And lastly, try to document the experience of using Kubernetes. So I've been experimenting also with Kata, with micro KS. So this is basically a Kubernetes distribution by Canonical that is very easy to use because you just need to install it as a snap, the same as I did for Kata. So you can have a single node Kubernetes deployment that you can easily test, remove. Everything is, as I said, immutable. So it's interesting so that I can validate all these steps that I showed using Kubernetes, which has a very different syntax and workflow, but it's more scalable when you're talking about multiple machines. And I think that is all for now. Thank you.
All right. Thank you so much, Marcos, for going through that. Certainly, it looks like you've made a lot of progress and made some good notes. And somebody had already asked if they can access that tutorial, so we'll make sure we get the.
It's public, and I'll put it's on the presentation, slide 20. So make sure to be there, and also we can put inside the same drive, that you put the files. You can put a document, so it can be easily accessible by everyone.
Okay. So Richard has his hand raised. Richard, I'm going to unmute you. All right, go ahead, Richard. You can unmute yourself.
I thought I read on one of your slides that you support a rootless mode. And then during your user interface showcase, I saw you using sudo at least several times. Were you showing us not the rootless mode?
So yes, so I gave a lot of different overviews of the tools. So I don't maintain anything of this. It's all, I would say, community projects. I'm just integrating them. So Nerdctl has a rootless mode for running traditional containers, runc containers. But if you want to run Kata containers, the rootless mode is not supported yet. It's on their roadmap. So if I say that Nerdctl support rootless modes, I could probably put here using runc. So it basically it means this. It's limited rootless mode. I'm not using that because I want to access some physical devices and some advanced features that would not be enabled in rootless mode. So rootless mode is a very, I would say, subset of features that you can have, basically if you want to run traditional containers. But in this sense also, I'm trying to expose the rootless means it's not like this that I can run, sorry. So rootless mode is not running Nerdctl without root. It's actually that the container process doesn't have root access. So it's a little bit different thing. So that all your containers, they don't have any process that has root control. So I'm not using that. I'm just advertising that as one of the features that Nerdctl brings, and they also advise that on the main documentation. But maybe it gave a wrong idea that I would be using the rootless mode. It's not the case.
Thank you for clarifying.
All right, thanks for your question, Richard. If anybody else does have any other questions, use the hand feature or type it into the chat. I'll replicate Michael Sinatra's question that he asked on the mailing list because he wasn't able to be here today. So he was interested in knowing why you're not comparing like for like, why you aren't using a 5.17 kernel on both the bare metal and the containerized system.
That's a good question. So there is, I think, two ways to answer it. So one way is that I don't want to change my physical environment. Actually, I did it, but I didn't got the row set, the whole set of benchmarks. So just before the demonstration, I booted into a 5.18 kernel so that I can compare it. But then I got onto some issues that I'm also seeing on the virtual environment. So I need to troubleshoot a little more the tuning, because I think that for 5.18 on bare metal, I have to do something different. But the thing is that I'll probably do that test. I didn't do it yet because before on the presentation, as I said, on this environment, I was using Ubuntu. So actually, I was doing the bare metal 5.4 compared to SRV 5.4, and all of these was 5.4. So I didn't need to change much to have a baseline. Right now, since Kata moved to 5.15, and also I'm running on a CentOS bare metal, I have a bigger difference between those environments. So I'm trying to replicate everything, but couldn't got all that ready yet. But I'll try to run those tests and compare soon. From my Ubuntu-based tests, I never could got the same results that this virtualized custom kernel, but yeah, I could get a very similar than the bare metal. But I'll try to do that, because I did this, I think, in February, and kernel 5.17 was still on release candidate. And yeah, there were some limited ways to do that. And right now, I tried to do the presentation and other stuff, so I couldn't do everything. So I'm trying to compose here a spreadsheet with all the scenarios and try to do graphs. So the idea is to have 1, 2, 3, and 4 flows with iperf and iperf3. Start doing that, but take a lot of time. And then the idea is to compare 2 scenarios, one with full package for MTU 9000, and one with the minimal one, so that I can stress the CPU or the I/O. So I can be bound to 2 different constraints and try to see. One good thing to know is what the tuning helps and what it doesn't. So have different scenarios helps you with that. And also I'm trying to do some different affinity here to put the application in the same core as the NIC interrupts. So that's not advised. When you have a really big application that uses your whole machine, that always happens. But also I'm trying to put on different cores the interrupts and the applications. So the idea is here, if you want to benchmark something in a controlled environment, it's easy to have enough CPUs to run 4 8 threads and have 4 8 threads dedicated to the NIC. But when you have a very busy machine, what you can have is guarantee as few CPU as possible for application and interrupts. So the idea here is to see what is the impact of that, in the sense that Cubic or Reno, HTCP, they behave very well when you are on a dedicated core. They don't have any time sharing with other processes, but they have a big degradation or a considerable degradation when you have something interrupting the kernel. But on the other side, BBR, BBRv2, they probably will be better on that case. So if we have a non-busy environment, maybe HTCP, Reno, and Cubic will be the standards. But when you're talking about busy environments, production environments, and non-dedicated environments, I expect with this also research here, try to come up with some, I would say, better performance for degraded scenarios.
All right. We don't have any other questions right now. If anybody has any last things they want to ask, please type them in. While we're waiting for anybody else, there will not be a talk next week, but we will have one on the 10th. The team from Globus and the University of Chicago is going to be talking about the migration path from Globus Connect Server 4 to 5. So if that's going to impact anybody's deployments at their universities, please certainly tune in for that one. And it looks like we don't have any more questions. So thank you again, Marcos, for being able to present this and send along those slides and those links. And I'll make sure that everybody gets a copy of them so that they can try this out and give you some feedback.
Thank you a lot, Jason. And thank you, everyone.
All right. Everybody have a good weekend, and we'll talk to you in 2 weeks.